20 years ago, just for fun, I actually taught myself to read Hangul, but I think since then I've forgotten almost everything. But it's good to see everyone here. Thank you all for coming. What I hope to do today, and also thank you, Dean Lee and Professor O for the introductions. What I hope to do today is chat with you about some opportunities in AI that I'm excited about. So I've been saying for quite a few years that AI is the new electricity. One of the difficult things to grasp about AI is that, is that it is a general purpose technology, meaning it's not just useful for one thing, it's useful for many different things. Just like electricity 100 years ago. What's electricity good for? It's not useful for just one thing. Sorry, let me try to get rid of this notification. Okay. It's useful for many different things. And let me start off by describing to you the technology landscape as I see it, and then say more about some of the opportunities. There's a lot of hype and excitement about AI, and I think a good way to think about AI is as a collection of tools. So the two most important tools today are probably supervised learning, which is good at labeling things or recognizing things, as well as generative AI. If you work in or study AI, you may have heard of other tools, but for today's presentation, we don't need to worry about them. And what I want to do today is focus more on supervised learning and on generative AI. Supervised learning is a technology that lets us compute input to output mappings, or input A to output B. For example, you can input an email and have it output whether or not it is spam. Or the most lucrative, most financially profitable application I've ever worked on may be online advertising, where you can input an ad and have it output whether someone will click on it to drive more relevant advertising. For self-driving cars, we can input the sensors from the vehicle and output the position of other cars. One project that my team worked on is ship optimization, where you can input the ship route and output the fuel consumed and use that to help ships find more optimal routes. Also did a lot of work on inspection in manufacturing, where we can input a picture of a phone and have it output, does this phone that we just manufactured have a defect? And we do this in automotive manufacturing, many different types of manufacturing. Or if you want to build a system for reputation monitoring of food reviews, you can input restaurant reviews and maybe output positive or negative sentiment. So this is supervised learning. Just to walk through one specific example, if you want to build a restaurant review sentiment tracking system, this is what you would do to build an AI system. You would first come up with a set of data with restaurant reviews, saying the Sundubuchi day was great, so that has a positive sentiment. Or if someone says, so slow and food so that's negative, or my favorite japchae, that's positive. And so if you're building an AI system, you would start off by getting labeled data like this. Here I have 3 data points. You may get maybe 100 or 1,000 data points, and then train or build an AI model to have it learn from this data, and then find a cloud service to deploy the AI model. You can input, best function GD I've ever had, and output. That's a positive sentiment. So what happened in the last decade is, I think the last decade was the decade of large-scale supervised learning to label things. And what happened was, about 10, 15 years ago, we found that if you have a lot of data and feed it into a small AI model, its performance would get better, but it would flatten out, it would plateau and stop continuing to get better. So about 10 years ago, I started and led the Google Brain project to build and scale up deep learning neural networks at Google. And the primary mission I set for the team back then was to build really, really large AI models. And that recipe turned out to work well, and this recipe of scaling up data and compute has driven a lot of progress in AI in the last decade. This present decade is turning into maybe the decade of generative AI. So I hope many of you will have tried tools like ChatGPT or Google's Bard, but in text generation, you can input a prompt, I love eating, and if you run it multiple times, you get Gaobi, Doso Bibimbap, Gaobi, and that's the AI output. Now, I know that there's a lot of excitement about this technology, and this fantastic technology I want to take just half a slide to explain in more detail the main parts of how this text generation process works, which is that generative AI is actually built by using supervised learning, that input A to output B learning to repeatedly predict the next word. So for example, if the AI reads on the internet, my favorite food is gochujang samgyeopsal, then this would create multiple data points. One data point is, if you see my favorite food is, what's the next word? Well, in this case, it's gochujang. If it sees my favorite is gochujang, in this case, the next word is samgyeopsal. And in this last example, the next word is gray. And so if we train a very large AI system on a lot of data, hundreds of billions of words, or for the largest models, sometimes more than 1 trillion words, then we get a large language model like ChatGPT. And there's some other technical details I'm skipping. For example, rather than predicting the next word, technically we predict the next something called a token. And then there's a technique for further refining the output to make the systems more helpful, honest, and harmless. But leaving aside the additional technical details, what I just presented, repeatedly predicting the next word, that's what is at the heart of modern large language models. So many of you will be familiar with ChatGPT as a consumer tool, meaning you can go to the website and use it. And I think it's a fantastic consumer tool. What is less widely appreciated is that prompting, writing these prompts, is also revolutionizing AI applications. In other words, it is also a fantastic developer tool, not just a consumer tool. So if you're building a restaurant review system like I was describing, this is what the typical workflow of an AI project would look like. You would get labeled data, take maybe a month to get thousands of examples, and then training the AI model, that might take 3 months to tune it, get it to work really well, try out different AI models, and then finally finding a cloud service, like AWS or Azure, GCP or some others, to run it, run robustly. That might take another 3 months. So typical workflow of a commercial grade robust AI system often takes 6 to 12 months, and many teams I led, we took about 6 months to 12 months to build and deploy an AI system. But with prompt-based AI, the workflow, which I'll show in a second as well, is you specify a prompt that takes minutes or hours, and then you can deploy the model to production in maybe hours or days. And so there are a lot of projects that used to take me and my teams 6 months to build, that today many people can build and deploy in maybe about a week. So let me just show you, very concretely what that means. And I know you were probably not expecting me to write code in this presentation, but let me go ahead and do that. So this is all the code I need. This is all the code I need in order to run a sentiment classifier. Let's try on my phone. It might work. It might work. Let me try. All right. So I'm going to have 2 lines of code to load, some tools from OpenAI, and then I'm going to write a prompt. So I have to say, my prompt says, classify the text below, delimited by 3 dashes, as having either a positive or negative sentiment. I've never tried this before, so SNU Data Science. That's fantastic. All right, and then I'm going to run it, and I'll show the internet. Oh, good. All right, thank you. I've never run that before, so thank you. Generative AI goes out. And you saw, this is all the code it takes now in order to build a sentiment classifier, and it'll take someone maybe 30 seconds, maybe minutes, to write and then deploy this and start making predictions about sentiment. So about 2 months ago, maybe 2-3 months ago, working with some people at OpenAI, we wound up launching a course on prompt engineering. using ChatGPT to build applications, and we had about 500,000 enrollments in 2 weeks, making this, as far as I know, the fastest growing course in the history of online education. And I think that what I'm seeing right now is that all around the world, because these tools are available, there's a lot of interest in learning to use these tools better. And so over the last several months, really since early this year, my team at deeplearning.ai has been working with many industry experts, including people from OpenAI, AWS, LangChain, Lemon, also quite a few others that we're collaborating with that we have not yet announced, to try to take the best practices in how to develop applications using large language models and create and share this knowledge online freely. Now, I mentioned just now that when about 20 years ago, I actually learned to read Hangul, but sadly my Korean is not very good. But there is one announcement I want to make together with Team D and Professor O. Do you want to join me on stage? So, as over the last few months, I was very interested, seeing the excitement of AI in Korea specifically. My team at deeplearning.ai really wanted to see what we could do to support the Korean AI community directly. So when we wanted to make more of our materials available in Korea, the first thing I did was obviously reach out to Seoul National University to see if it would be possible to collaborate. And I am very happy to announce that thanks to the hard work of the students, we now are putting in place career translations for our courses. And I want to thank Dean Lee and Professor O for having the students collaborate with us on this.
이렇게 훌륭한 코스를 준비를 해주셔가지고 여기 그 앤드류 교수님 코스 들으신 분들 많죠? 없나요? 그러니까 그거의 시권, 그러니까 연속편이라고 생각하시면 되고 저희가 조금 기여를 했습니다. 그러니까 우리말 트랜슬레이션에 대해서 조금 기여를 해서 이 코스가 이제 그 유튜브나 이런 데 올라오게 될 텐데 많이 봐주시고 뭐 보지 말라 그래도 보실 것 같은데 뭐 틀린 거 없죠? Is there anything wrong? Something wrong? No. So, 그러니까 어쨌든 많은 성원 있으시고 많이 봐주시기 바랍니다. 그리고 뭐 트랜슬레이션이 잘못됐으면 언제든지 말씀을 해주시고 없는 잠깐 한 말씀 하세요. 네, 감사합니다.
So really, and thank you very much for all the Seoul National University students that were helping with this translation effort. And I'm very committed to doing what I can to engage more with the community in Korea and do more things together. So what I'd like to do is next is share with you what are some opportunities in AI that I see and are excited about. In this diagram, the size of these two circles represents the value that I think these different AI technologies have today. The vast majority of value, commercial value from AI technologies today is from supervised learning. For a single company like Google, this can be worth more than $100 billion a year. And today, there are millions of developers working on this, and so it's massive value with a lot of momentum, a lot of progress still. Generative AI is the new entrant and it's much smaller right now, but it seems to be positioned to grow very rapidly. And again, there's some other technologies that we don't spend less time describing today. So if these circles is the value of these technologies today, this is what I think it would grow to in the next few years. Because supervised learning has millions of people working on it, I think it might double over the next few years. So this will grow from really massive to even more massive. Whereas generative AI is starting quite small, but I think will much more than double in the next few years because of the number of people doing research and innovating. 3 years is a very short time, and if we look out 6 years, then maybe generative generative AI will continue to compound and be even vastly greater than this. But in this diagram, this light-shaded region, the light-shaded green and the light-shaded orange, both of these are where there are opportunities, both for research groups and for startups and for large businesses to create a lot of value. One thing I hope you take away from this part of the presentation is AI technologies are general purpose technologies, meaning that they're useful for many different tasks. You saw just now the long list of things we could apply supervised learning to as well. And so a lot of value remains to be created using supervised learning, and a lot of the work that remains ahead of us is to identify the use cases where it's valuable and then to build to those use cases. And even though we've not yet finished finding all the valuable use cases of supervised learning, generative AI gives us another general purpose technology too, and a lot of the work that lies ahead of us is to identify and build a lot of those use cases. Now, there is one caveat, which is that there will be fads, there will be short-term fads along the way. I don't know if any of you had heard of Lensa, but this is an app that was very popular last year that will let you upload a few pictures of yourself and then draw a cool picture of you as a scientist or an astronaut or something. And so its revenue took off like that through December, and then it collapsed shortly after. And I think this is because while Lensa was a good idea, it was a very thin, very simple software layer built on top of someone else's very powerful APIs. And even though it was a good idea, it didn't last for a very long time. When I think about fads in generative AI, I'm often reminded of when Steve Jobs gave us the iPhone, and there were fads then too. So when there was the iPhone, someone wrote an app that I paid $1.99 for, not sure you can see this, but to turn on this LED flashlight and turn the phone into a flashlight. And that was a good idea, but it wasn't a long-term business. But when we got the iPhone, there were also other people that figured out how to build Airbnb and Tinder and Uber, and those are the really deep, really difficult products and businesses that ended up creating long-term value. And the thing that excites me about generative AI is with this wave of new technology, there's an opportunity for all of us really to build those really deep, really difficult businesses or products that could last for a very long time. So that's one major trend. Generative AI does a lot of work to be done to identify and build concrete use cases. I want to share a second trend with you that I find exciting, which talks about why isn't AI more widely adopted yet. So we've been talking about AI for 10, 15 years already, but a lot of the value of AI today is still concentrated in consumer software internet companies. Companies in the US like Google, Microsoft, Facebook, obviously Kakao, Naver. But when you look outside the consumer software internet industry, AI adoption isn't that widespread yet. So why is that? So if you were to take all current and potential AI projects and plot them and sort them in decreasing order of value, you get a curve that looks like this, where to the left are projects like online advertising and web search and online shopping product recommendations at Amazon, where you can write one piece of software and apply one piece of software to 1 billion users and generate massive financial value. So about 10, 15 years ago, my friends and I had figured out this recipe of hiring dozens or maybe hire 100 engineers, write one piece of software and apply this to a very large number of users, and this turns out to be very valuable. But this recipe of having a large group write one piece of software doesn't work once you go outside consumer software internet, because almost no one else has tens of millions or 1 billion users you can apply one piece of software to. Instead, these are the types of projects I'm excited about and have been working on. We're actually working with a pizza maker that needs to take pictures of the pizza to make sure that the cheese is spread evenly. And this turns out to be about a $5 million project, which is quite valuable, but you can't hire 100 engineers to work on a $5 million project. Another example, a real example, we're working with an agriculture company that we figured out that if you can use cameras to find out how tall is wheat in a farm, and you can adjust the harvester to chop off the wheat at the right height, then you get more food off the field, so it's more food for the farmer to sell, and it's also better for the environment. But this is another $5 million project, so hiring dozens of engineers to work on this would not make sense. And similarly, materials grading, cloth grading, sheet metal grading. So what I'm seeing is that, unlike the billion-dollar projects on the left, which we have in consumer software internet, in most other industries, we have tens of thousands of $5 million projects. And so I think the total value of all the projects in the tail to the right is even greater than the total value of the projects in the head on the left, but we have not had a way to economically execute all of these projects in the tail. So the trend I'm seeing that I find very exciting is that the AI community is building better tools, low-code and no-code tools, that enable the user to do the customization. So rather than, say, me having to build these projects one at a time, the tools are getting to be good enough that the IT department of the pizza maker can train an AI on their own pictures of pizza and build their own custom AI to realize its value. And by the way, the pictures of the pizza don't exist on the internet, so Google and Bing don't have access to these pictures, but the IT department of the pizza maker, if they can use prompting or a technology called data-centric AI to build a custom AI system, then they can realize this value. So in terms of these two trends, AI as a general purpose, AI as a general purpose technology, and second, these tools that are enabling us to take AI from just consumer software internet into many other industries, what can we do? So about 5 years ago, I realized that many valuable AI projects are increasingly possible, and this is even more true now with generative AI. And the puzzle I want to solve was, how do we get all these projects done? So having led AI teams in Google and Baidu, I felt I couldn't imagine how I could operate one team or operate a team in a big tech company to go after such a very diverse set of opportunities in very different industries. And so I felt that starting with new companies is an efficient way to go after opportunities in sectors as diverse as maritime shipping and financial services and education and on and on and on. And so that's why I started AI Fund 4 or 5 years ago, to build companies to go after these opportunities. But of course, I think incumbent companies, existing large companies, also have many opportunities to integrate AI into the existing businesses. But what does this mean? So this is what I think of as the AI stack. At the bottom layer is the hardware, semiconductor. This is very capital intensive and very concentrated, meaning it takes a lot of resources to do this, and there's a small number of winners. I think this is a good sector, but given how capital intensive it is, I personally tend not to play there. There's also the cloud infrastructure, which is also very capital intensive, needs a lot of resources, and very concentrated. So I personally don't play there either. And then there's developer tools. So OpenAI, what I just showed you, is one example of a developer tool. And I see the developer tool sector as very competitive. Look at all the startups chasing OpenAI, but if you have a technology advantage, then you have a shot at being one of the huge winners. I personally tend to play here rarely, but carefully, and only when my team thinks we have a unique technology. And it turns out that even though most of the media attention, the press tends to talk about infrastructure and developer tools, I think the only way for this layer to be successful is that the application layer is even more successful. Because for infrastructure and developer tools to be profitable, the application layer has to generate even more revenue to be able to pay them. And so what I spend a lot of my time doing is working with partners to build out different applications of AI. Maybe one fun example is Amorai, which is a startup. I was actually texting the CEO of Amorai just last night. This is a company that does AI applied to romantic relationship coaching. And this is an interesting case study because I just want to point out, as an AI person, like I don't know anything about romantic relationships. And in fact, if you don't believe me, ask my wife. She will confirm that I know nothing about romance. But when AI Fund decided we want to do something on this sector, we wound up working with the former CEO of Tinder, Renate Nyborg, and with my team providing deep expertise in AI. And Renate, because she ran Tinder, she knows more about relationships than probably anyone else I know. We're able to work together to build something quite unique using AI to help people with relationship mentoring. And so over the last few years, my team has refined our process for building startups. And what I want to do is just share with you how we work to build new startups, and I hope that this might be useful to some of you as well. Or maybe we could collaborate on some ideas as well. But so my team's always had access to a lot of ideas for startups, internally generated, or we go to friends and we share some of those ideas with us. I want to walk through our process with one case study, which is a company, Bearing AI, where this idea was suggested to us by a conglomerate, Mitsui, that operates a line of ships on the ocean. And this is another one of those ideas. I would never have come up with this idea myself. I've been on a boat, but what do I know about maritime shipping? But so our friends at Mitsui came to me and they said, Andrew, you should build a business to use AI to make ships more fuel efficient by helping them select better routes. So in a typical process, my team then spends about a month doing market and technical validation, so make sure the idea is technically feasible and make sure that talk to the users and customers to make sure there's a market there. And if we conclude that there is a market there, then we will recruit a CEO to work on this project with us. So we call the CEO founder in residence. But we recruited Dylan Kao, who's a great CEO, who's had one successful company exit before. And after recruiting the CEO, we'll spend about 3 months with them to build a prototype and have deep customer validation. And if the startup survives this stage, it survives about 2/3 of the time, we then fund the company, and that gives the company resources to hire key executives and start to get more customers, and then they hopefully will then, within 12 months, sometimes even much faster, go out to raise the next round of funding. And so I found that for my team, we focus on the AI technology. And I find that AI technical expertise is important because we have to be able to figure out, is this idea technically feasible, and we can pretty much always ensure that AI tech is built quickly and well, and we've always helped our teams bring in strong technology teams. I just to share with you one key idea for how we engage in those startups as well, which may be surprising because this runs opposite to the standard advice for design thinking, which is we like to work only on concrete ideas. So, for example, if someone says, hey Andrew, you should work on AI applied to financial services, I don't know what to do with that because I'm not an expert in financial services, so it would be very inefficient for me to learn enough about the sector to come up with a concrete idea. But if someone comes up with this idea, one of my partners wrote this as a slight joke. This is not a serious idea, but he said, let's eliminate commercials by automatically buying everything in exchange for not having to see any ads. It's not a serious idea, but it is a concrete idea. And we've learned that concrete ideas can be validated or falsified very efficiently. It gives a clear direction to build and see if it works. And also, it turns out there are a lot of subject matter experts in the world that will have often thought for months or even a small number of years about an idea, but has not yet had a build partner. And when we get together with them and they share the concrete idea with us, we can often validate it and then execute it very quickly with the partner. So we found that this process of building startups, it works, and it actually just repeatedly allows us to work with partners and create exciting startups. So I'm going to skip over. So just one last thing, and then we'll go to Q&A. We're just going to say a couple words about risks and social impact. AI is a very powerful technology, and so my team takes responsible AI seriously, and we only work on projects that move humanity forward. So we have repeatedly killed projects that we assess to be financially sound, but based purely on ethical grounds. So I can share some examples later, but there have been some surprisingly bad ideas that are financially sound that we just really wasn't a hard decision to decide to kill. And I think there's a lot of discussion by regulators around the world, including in Korea, about AI. And I think AI today has problems with bias, fairness, and accuracy but the technology is improving quickly. It's actually quickly, rapidly becoming less biased and more fair and more accurate. But of course, this is something we still have to pay attention to and keep working on. But in terms of the risk of AI, I think the biggest risk is that it will disrupt many occupations. This is a diagram from a study done by some of my friends at the University of Pennsylvania as well as OpenAI. And the x-axis is the annual wage, annual salary. The vertical axis is how exposed that job is, how exposed the task in that job is to AI automation. Whereas earlier ways of automation tended to mainly disrupt lower wage tasks, lower wage jobs, this wave tends to be the higher wage jobs that are more susceptible to automation. And so I think it's important that even as we build these amazingly valuable things, to the extent it disrupts people's jobs as a society, as citizens, I think we're in obligation to make sure that people are well taken care of. And this is my last slide. The other discussion about risk of AI is AGI and will that cause maybe even human extinction? I think AI can do anything a human can do. It's still decades away, maybe 50 years, 30, 50 years away, maybe even longer. But I do hope we will get there in our lifetimes. And because of this, there's been discussion about whether AI creates extinction risk for humanity. I think this has been wildly overhyped for a couple of reasons. So first, human society, we have lots of experience steering very powerful entities like corporations and nation states. A corporation is much more powerful than any single person, but we've managed to steer these organizations to mostly benefit people, and I'm confident we will too for AI. And second, AI develops gradually. So the hard takeoff scenario of where it's only working so-so today, but suddenly one day it achieves super intelligence and takes over the world, that's not going to happen. So it'll come slowly, it gives us lots of time to make sure it's well managed. And then lastly, if you look at the things that are actual existential risk to humanity, things like, fingers crossed, the next pandemic, which Korea managed that so well, but really, the next pandemic, or maybe climate change, causing a lot of depopulation of many parts of the planet, or much lower risk, maybe another asteroid, doing to us what the asteroids did to the dinosaurs. If you look at the actual extinction risk to humanity, I think AI will be a key part of the solution. So I think if we want humanity to survive and thrive for the next 1,000 years, rather than thinking only about how to slow AI down, I think we should actually make AI go as fast as possible. So with that, I'm excited to be here in Korea because I think that Korea as a nation has tremendous momentum and excitement about AI, and I think looking forward, hopefully there'll be many things we could do together. And so let me just say thank you all very much.
훌륭한 강연을 해주신 앤드류 교수님께 감사드립니다.